The proposed MMREC framework integrates large language models, LLMs, and deep learning techniques to enhance the accuracy and relevance of recommendations in a multimodal recommender system. By leveraging LLMs, the framework efficiently extracts and integrates text and image information, unifying diverse modalities in a latent space to simplify the learning process for the ranking model. Experimental results demonstrate the enhanced discriminative power of the model when utilizing multimodal information, particularly in improving the false positive rate in the case of imbalanced datasets. The MMREC model utilizes a sentence transformer to convert textual information into embeddings in ResNet 50 to transform images into continuous data. The model then employs LLMs to extract pricing information from user reviews and summarize important information from textual and visual reviews, reducing noise and unifying the embedding technique for different modalities. An additional sparse feature is introduced to categorize each restaurant into one of 11 categories. To mitigate the risk of overfitting, the model employs dimensionality reduction techniques, concatenating the embeddings from both text and image encoders and feeding the combined tensor through a multi-layer perceptron, MLP. The experiment section evaluates the model's performance under different conditions, including various dropout rates, weighted loss functions, and baseline versus proposed models. The dataset is highly imbalanced, with only 1/8 of the data points associated with false labels, and the authors experiment with different weighted loss functions to balance the impact of each class on the loss function. The proposed approach aims to improve the performance of the recommendation task by utilizing LLMs for summarization and contextual understanding of user reviews and images. The model's performance is evaluated using a comprehensive dataset tailored for restaurant reviews analysis, collected from Google reviews and published on Kaggle. The proposed multimodal recommender system, MMREC, integrates a large language model, LLM, with the deep learning recommendation model, DLRM, to enhance restaurant recommendations. This system utilizes dense features such as the number of reviews, average user and business ratings, and sparse features like restaurant categories. It also incorporates embedding features generated using LLM and multimodal models, including user-reviewed text, business-reviewed text, and review image features. The performance of MMREC is evaluated against both training and testing sets, demonstrating improved accuracy and reduced false positive rates compared to the baseline model. The addition of new dense features, such as price tags, and sparse features, like restaurant categories, contributes to these improvements. These features are generated using prompt engineering with the GPT-3.5 Turbo 1106 model, allowing for a more nuanced understanding of user preferences and business characteristics. The results indicate that MMREC outperforms the baseline model in terms of accuracy and false positive rate, suggesting that incorporating LLM-based features can effectively enhance recommendation systems. However, the model still has limitations, such as requiring a large amount of data for training and potential biases in the generated features. Future work could involve addressing these issues and further refining the model to improve its performance and applicability. In the realm of deep learning-based recommender systems, MMREC leverages the capabilities of LLMs to process multimodal information effectively. This innovative framework integrates textual and visual data into a unified latent space, enhancing the performance of the model. The utilization of LLMs allows for the summarization of user reviews and the generation of textual information from images, providing a more comprehensive input for the model. This approach significantly reduces the false positive rate in the model, particularly due to the ability to extract valuable insights from negative reviews and the summarization capabilities of LLMs. The proposed model outperforms the baseline model in terms of false positive rate, both in the train and test sets, with the best model achieving a false positive rate of around 2%. The model with the highest accuracy, however, is the baseline model with a 0.5 dropout rate in square root weight, achieving 93.47% accuracy with a 37.58% false positive rate against the test set. The proposed model also exhibits a clear overfitting with a lower dropout rate, resulting in increased accuracy and a reduced false positive rate. The paper concludes that the integration of multimodal data and the utilization of LLMs can enhance the performance of deep learning-based recommender systems, especially in scenarios involving imbalanced datasets. This research paper presents a comprehensive review of existing literature on recommender systems, focusing on the integration of large language models, LLMs, and multimodal data. The authors provide an extensive list of references, covering various aspects of recommender systems, including deep learning-based methods, graph convolutional networks, and knowledge-enhanced prompt learning. The paper highlights the importance of incorporating multiple modalities, such as text, images, and user behavior, to improve the accuracy and diversity of recommendations. Several studies are cited that demonstrate the effectiveness of LLMs in recommender systems, including their ability to capture complex user preferences and generate personalized recommendations. The authors also review various techniques for incorporating knowledge graphs and external knowledge sources into recommender systems, including graph-based methods and knowledge-enhanced prompt learning. These techniques are shown to improve the accuracy and diversity of recommendations by leveraging the rich semantic information contained in knowledge graphs. The paper concludes by highlighting the limitations and future directions of existing research, including the need for more effective methods for integrating multiple modalities and knowledge sources, and the importance of addressing issues related to fairness, transparency, and explainability in recommender systems. Key concepts and methodologies discussed in the paper include large language models, LLMs, and their applications in recommender systems, multimodal data integration and fusion techniques, graph convolutional networks and knowledge-enhanced prompt learning, knowledge graphs and external knowledge sources, deep learning-based methods for recommender systems, and interpretability and transparency in recommender systems. The paper provides a comprehensive overview of the current state of research in recommender systems, highlighting the potential of LLMs and multimodal data integration to improve the accuracy and diversity of recommendations.